Right. So this is how the session is going to work. So let me introduce the session for you first, right? So I will be focusing on the lessons that is going to come for grade 10 and 11. Only those lessons, right? I'm not going to teach you everything, right? I'm going to teach you the lessons that you need for grade 10 and 11 so that you have a basic foundation for your grade 10 and 11, right? So that's the main focus of this series of session. So it will happen as 5 classes. So this is the first class. So you will have more 4 classes every Monday, same time, right? So you will have more 4 classes there. So what are the lessons I will be discussing? So I just want to say that first, starting with unit 3. Unit 3, right? So that is nature and properties of matter. So this is the first lesson I will be starting with. Right? So this will take place for 2 weeks, right? So today is one day, right? So today is one day and it will be taking place for 2 weeks. So that means with today, you will have another day where I will be teaching you this lesson, right? And the second thing is, the second lesson I will be focusing on is the basic concept of forces. So that is unit 4, right? So this is unit 3. So then I will be teaching you unit 4. So that is basic concepts of associated with forces, right? Basic concept associated with forces. And then the third, so this will be your third class, right? And then the fourth class would be on pressure exerted by solids, right? And density. Pressure exerted by solids and density. So this will be your fourth class, right? And the fifth class will be refraction, because I think we already have conducted a seminar regarding reflection in like some days before. My sister has conducted a seminar, so I just don't want to repeat it. So if you have missed that, you can go to our YouTube channel, that is Sateha College, and you can find the lesson there. So I don't want to repeat reflection. So I will be just focusing on refraction. And if we have more time, the other unit I will be focusing on is human blood circulatory system. I'm not sure about this. I can't, give a word on this. But after we finish this part, and if we have time and stuff, we can do this as well, right? So this is the things which I will be covering in these free sessions. So free sessions you will have for 5 weeks, right? So continuously for November and December, you will have the free session. So grade 10 classes, like my theory class, I will be starting in January. So within December, you just get an idea, a basic idea of grade 9. So that grade 10 will be easy for you, right? So is there any doubt regarding that? So you can write this down. So these are the lessons we will be focusing on. Yeah, it's free for all 5 classes. It's free. So you can inform your friends to join as well. So it will be helpful for them. So maybe most of you all have missed these classes due to the pandemic. So it will be helpful for you also. Right? Okay, so let's start. Before I start, I just want to say, everyone, did you all get the tute? I sent the tute for everyone. Anyone who didn't get the tute? Anyone who didn't get the tute? Okay, so if you didn't get the tute, just leave me a message to this number. I will send you all the tute, okay? 2345 597. Leave me a message for this number. I can send you the tute, right? If you didn't get it, okay. Right, now listen. So when I'm teaching, right? When I'm teaching, if you have any doubt regarding what I'm teaching, please send a message to Asia Ali, that is the co-host. Send a message there. So I will be explaining you, I will be reading your messages, and I will be clearing your doubts, right? And at the same time, in between, I will ask questions. So don't be silent, okay? If you be silent, this session will not be effective. So what you should do is, whenever I ask you any question, you should reply to that question. So if you reply only, you will find out, okay, I understood this session. Okay, what she's saying, I can understand. So that mentality will come only if you reply to the answers. Don't be silent. And also, I know I can't hear you, but after I explain a certain part, if you have any doubt, I will give you a time duration where you can unmute and talk. Right? I will change the setting only at that particular time, so you can unmute and talk. So at that time, you can ask doubts as well. Right? But when I'm teaching, if you have any doubt, you can send me to the chat. Okay? And if I say you something like, say, okay, say this behind me, say it. Right? Don't just shut your mouth and wait. If you do that, then again, this session will be not effective. I know this is online. I can't see what you're saying. I can't see what you're doing, right? But this is for you, right? This is for you. So get the maximum out of it. So how can you do that? So if I say you to say something, repeat with me. Make some noise, make some noise. Make people who are surrounding you think, okay, she has what is she doing? What is she? So make them curious. Like you're studying, you should show them, right? So make some noise with me, right? And make sure before you go from the session that you have understood everything completely, right? Okay, so let's start. Okay, now let's make it as a story, okay? Because if you don't make it as a story, you will feel boring and you will say, okay, what is she teaching? We don't want that, right? We want to make this session very interactive. Okay, now think with me, okay? So now I'm teaching unit 3, okay? Okay, now look. Now say you want to build a house, right? So now say your family is trying to build a house, right? So the first thing what you need to build a house, or say there is a very special place which is going to be built, and they put in news, right? Okay, someone came and kept something. So what is the basic unit of the house? Now, when you want to build a house, what is the simplest unit of it? Yes? Answer me. What is the simplest unit of it? Now, what do they come and place? Now, say whenever they want to build a school or an educational center, they keep a big ceremony and they come and place something. What is that thing they place? Very good. Brick. Right? You place a brick, right? They keep a ceremony and say, okay, now the brick has been placed to build the house. Okay? So that means the basic unit of the house is what? A brick. The basic unit, what you can see, right? The basic unit of the house, what you can see is what? Brick. So did you understand that? Did you understand that? If you join several bricks together only, you're going to build a house. If you join several bricks together, you're going to build a house, right? Okay, now think. If you take a substance, now say example, you have taken the same brick, right? You have taken the same brick. So now they found out that this brick, now this house is made up of bricks, right? So that means this brick also should be made up of what? Substances, right? So that means they told when you take a substance, so the simplest form of the substance, that you call it as what? Atom. That you call it as what? Atom. So you have a house. To build the house, the simplest form you need is a brick. But if you take the brick, inside the brick, you will have particles, right? So the simplest, the basic unit of the substance, you call it as what? Atom. So if you have several atoms combined together, that only will make that substance. Did you understand? Did you understand? So what is an atom? Say with me. So atom is the basic unit of a substance, right? So what is an atom, everyone? Repeat with me, make some noise. So what is an atom? Atom is the basic unit of a substance, right? So now listen to me. So who is the scientist who discovered this? Now, for everything what you discover, you have a person, right? So the scientist who discovered this is John Dalton, right? Who is the scientist who discovered this? John Dalton. John Dalton is the scientist who discovered this, right? Now, what did he say? Now, let's see what he's saying. He told, if you take a substance, the simplest form of this substance is what? an atom. He told, if you take a substance, the simplest form of the substance is an atom. Now I'll ask you one question. If I take a brick and give it to you, I'm placing a brick in front of you. And I'm saying you, show me the atom. Can you show me the atom? I'm taking a brick and I'm keeping in front of you. Now, what am I saying? Show me the atom. Can you show me the atom? Can't. Why? Because an atom cannot be seen with what? The naked eye. What do you mean by naked eye? Without using any microscope or any specs or anything, an atom cannot be seen with the naked eye. So if I give you a brick and say you, mark the atom in the brick, so can you mark the atom? Can you mark the atom in the brick? No, you can't mark it. You can't mark it. So what did John Dalton say? He told, okay, if you take a brick or any substance, the simplest form of this substance is what? An atom. The simplest form of this an atom. Can you see the atom with the naked eye? You can't. You can't see the atom with the naked eye. So he told atom is the simplest substance and you can't see with the naked eye. Also, is everyone clear with that? Is everyone clear with that? Any doubt? Any doubt up to now? Right, good. Right, now listen. But now the story becomes twisted. But after the introduction of microscope, now John Dalton, he found out the atom before the introduction of microscope. He didn't even see it. He didn't even see the atom. He just told, now when you take a substance, there is a particle which you can't see. And he named that as an atom. But did he see it? Did he see the atom? Did he see the atom? No, he didn't see the atom. So what happened is, after the introduction of microscope, now they have introduced the microscope. So after the introduction of microscope, they found out, now after the introduction of microscope, now you can see the atom. Okay? And they found out inside the atom, there is some particles. Come again. Now, what did John Dalton say? He said, the simplest, the smallest, the basic unit of a substance is atom. And he said that is the smallest. And he told, can you see it with the naked eye? Can you see it with the naked eye? Can't. He told you can't see it with the naked eye. But after the introduction of microscope, they were able to see the atom. Now, naked eye, so microscope is not naked eye. So you were able to see the atom. But what is the special thing that they found out? That they found out inside the atom also, there are some other particles, right? So that they named it as what? Subatomic particles. They named it as what? Subatomic particles. Did you understand? So what are subatomic particles? The particles that are found where? The particles that are found? Yes, answer me in the chat. What are subatomic particles? The particles that are found? Very good. The particles that are found inside an atom, right? That he named it as what? Subatomic particle, right? So now what happened is, now scientists, they were finding out, okay, what is this subatomic particle? So then what happened is, 3 scientists, they found out this subatomic particle. And they named it as protons, neutrons, and electrons. Okay, they named it as what? Protons, neutrons, and electrons. Okay, now can you say me the story back? So let's say the story together so you will not forget. So what happened? John Dalton, he took a substance. And then he found out the simplest, the smallest unit of the substance. He named it as what? The basic unit of the substance. He named it as what? Yes, answer me in the chat. The basic unit of the substance, he named it as what? Atom. He named it as atom. Was he able to see the atom? Was he able to see the atom? No, because atom cannot be seen with the naked eye. naked atom. But after they introduced the microscope, what happened? After they introduced the microscope, they found out that there is what? After they introduced the microscope, they found out that there is subatomic particle. So what are subatomic particles? What are subatomic particles? Very good. The particle, the small particles which are found inside an atom. So what are the three names for the subatomic particles? Say with me. What are the three examples? What are the three subatomic particles? Proton, neutron, and electron. Did you all understand up to that? So now the story has stopped here. Are you all clear up to here? Are you all clear up to here? Okay, very good. Right. Now listen. Now listen. Now someone is saying you, right? Someone is saying you, okay, this is that. Someone is saying you, this is that. Now they are saying, you have this also inside it. You have the proton also inside it. You have the neutron also inside it. You have the electron also inside it, right? Now, what is your problem? What is your problem? Should I place the proton here, or here, or here? Or should I place the neutron here, or should I place the electron here? So now that is a problem, right? Now they told you have protons, neutrons, and electrons, but you don't know how they are placed. You don't know whether you have protons here or neutrons or electron. You don't, right? And then what happened is another scientist, right? His name was J.J. Thomson. What is his name, everyone? His name was J.J. Thomson. He told, okay, let's think about this. Now, I want to make a pudding. I want to make a pudding. Now, inside this pudding, I should put the plums. Okay, inside this pudding, I should put the plums. Okay, before that, look. Now, after they found out the subatomic particle, they found out that the protons were positively charged. It had a charge. It was positive. The neutrons, it did not have a charge. And the electron, it was what charge? Negative charge. They found out this also, right? So now this J.J. Thomson, he's coming front and he say, okay, now I know how they are found. So now he's going to introduce the atomic model. He's going to say how these subatomic particles are found inside that. He told, it's like a pudding. What did he say? It's like a pudding. Now, when you have a pudding, if you want to make the pudding, what do you insert inside the pudding? You can insert the plums, right? You can insert the plums. And he told, who are the plums? Plums are the proton, neutron, and electron, right? He told that plums were proton, neutron, and electron. And he named this atomic model as plum pudding model. He named it as what? Plum pudding model. So what is this plum pudding model? He told, an atom is a pudding. An atom is a pudding. Mixed with what? What do you have inside the atom? Mixed with? The pudding is mixed with what? Answer. The pudding is mixed with plums. So what are the plums? The plums were the proton, neutron, and electron. So that is what a plum pudding model says, right? So what is a plum pudding model, everyone? Say with me. An atom is a pudding mixed with what? Say with me. Mixed with plums. And the plums were the proton, neutron, and electron. So did you understand the story? Did you understand the story? So now, after they found out this, they were thinking how to put it in an atom. Then J.J. Thomson said, okay, wait. I will say you one thing. What to do? Okay, just imagine the atom is as a pudding, right? And what do you have inside the pudding? You have plums. So what are the plums? Plums are the proton, neutron, and electron. So that model, they named it as what model? Plum pudding model. Plum pudding model. So did you understand? So what is said in a plum pudding model? In a plum pudding model, you say that an atom is a pudding mixed with plums. The plums were the proton, neutron, and electron. Right. Now came the next problem. Now what was the next problem? Now one scientist asked him, okay, now you're saying these are the plums. No. Now plums are same or different? Plums are same or different? Now when you're putting plums, is the plums the same or you have different plums? Now say you're putting the same plums, same. But here, proton, neutron, and electron, are they the same? Are they like the plums? Are these the same? No. Why not? Because proton is positive. Neutron, no charge. Electron, negative. Can they be the same? Can they be the same? Can't. It can't be the same. Right? So now what happened is, now say example, now you have studied about magnets, right? Now if you have the north pole of a magnet and you come and keep it towards the south pole of the magnet, will there be attraction or repulsion? What's your answer? If you have the north pole of the magnet and you come and keep it towards the south pole, attraction or repulsion? Okay, I'll ask you one question. I'll give you some hint, right? Now you have a boy and a girl. Boy, girl, attraction or repulsion? Attraction or repulsion? Attraction, right? So same like that, if you have the opposite poles, it will attract. It will attract. If you have the same pole, now say you have a girl and a girl. Girl, attraction or repulsion? Repulsion, right? So they will go away. So same like that, if you have positive charge and negative charge, attraction or repulsion, same like that. Now these are opposite charges. Opposite charges will attract or repel. Very good. They will attract. Same like the north and south pole, right? Opposite charges will attract. Now, same charges will attract or repel. Same charges will attract or repel. It will go away, repel. Now, what happened? Now, what is the problem? Now, they know that proton is positively charged. Electron is negatively charged. So now, attraction or repulsion, now will they be distributed equally or will there be some attractions? Some attractions. So then they said, we can't accept this. The scientists told this is not correct. Why? Because proton is positively charged. Neutron have no charge and the electron is negatively charged. So how can we accept this? Then what happened? Plum pudding model was rejected. Did you understand why plum pudding model was rejected? Because proton, neutron and electron, they were different. So they can't be considered as plums. They can't be considered as plums. Understood? Did you all understand up to this? Right, good. So now say me before we go to the next part. So who introduced the plum pudding model? Who is the scientist who introduced the plum pudding model? Yes, answer me. Very good. J.J. Thomson. Now, what did he say? He said an atom is a, what did he say? He told an atom is a pudding. Good. Mixed with what? What do you have in mixed with? Plums. So who are the plums? Who are the plums? Yes, who are the plums? The proton, neutron, and electron. Then, was his model accepted for long? Was his model accepted for long? No, it was rejected. Why did they reject it? Why did they reject it? Because, yes, answer me. Why did they reject it? Because proton, neutron, and electron were different. So did you understand? Did you understand? Everyone, is it clear? Very good. Good. Right. Now what happened? Now atomic model rejected. No way. Now they have rejected. Now what will happen is, now another scientist came. His name was Ernest Rutherford. What is his name? Ernest Rutherford. What did he tell? He told, now this atom is like a planetary model. Now he named his model as a planetary model. Now I'll just first explain you what is the name planetary stands for. So this name planetary stands for the planets, the solar system. Now when you take the solar system, what do you have in the center? What do you have in the center? You have the sun in the center. And what can you say about the planets? What can you say about the planets in the solar system? Yes, they are revolving around the sun. The planets are revolving around the sun. So that's what he gave the name planetary model. Now let's study what is this planetary model, right? What is this planetary model? He told, okay, in the planetary model, in the atom, you will have a nucleus. What did he say? He told an atom consists of a nucleus. And he told this nucleus consists of protons and neutrons. Right? In the nucleus, what you have? You have the protons and neutrons in the nucleus. And then he told the electrons are revolving around the nucleus in energy orbital. Right? In energy orbital, you have the electrons revolving around the nucleus. Right? So, this is like where? This is like the, yes? This is like the, where? The solar system. You have the sun. And around the sun, what is revolving around the sun? What is revolving around the sun? The planets. So he named it as the planetary model. So what did he say? He told, when you take an atom consists of what? Answer me. When you take an atom consists of what? Nucleus. His name is Ernest Rutherford, right? So an atom consists of nucleus. So what do you have inside this nucleus, everyone? What do you have inside this nucleus? Do you have all three substances inside the nucleus? No. You have only the proton and neutron. Proton and neutron is present in the center. So that is the nucleus. That is acting like what? It's acting like the, yes? Very good. It's acting like the sun. Right? And then he told the electrons are revolving around the nucleus in energy orbital. This is an energy orbital, right? So he told the electrons are revolving around the nucleus in energy orbital. Did you understand? Did you understand? Is it clear? So what does the planetary model say? Revise with me. So that will be in your head for a long. What does the planetary model say? The planetary model says that an atom consists of what? The planetary model says that atom consists of what? A nucleus, right? The atom consists of a nucleus. So the nucleus contains what and what? What does the nucleus contain? Nucleus contains, very good, proton and neutron, right? The nucleus contains proton and neutron. Then what did he say? Then what is happening? Electrons are revolving. Electrons are revolving around the nucleus in what? In energy orbital, right? This one you call it as an energy orbital, right? The center, if you have something in the center, you call it as the nucleus. These are the names he gave, right? And he told the electrons are revolving around the nucleus in energy orbital. Did you understand? Did you understand? I'll explain you one more time. I'll explain you one more time, right? Then now what happened? J.J. Thomson, he was a scientist. He introduced a model for an atomic model. That was what name? What was the name given for the model which was introduced by J.J. Thomson? Yes, everyone. What was the name given for it? Very good. Think of your pudding your mother makes. Plum pudding model. Plum pudding model. So what did he say? An atom is a pudding mixed with, what do you have inside the pudding? Plums. So what was those plums? The plums are the proton, neutron, and electron. Then was it accepted? Was it accepted? No, it was rejected. Why was it rejected? Why was it rejected? Because proton, electron, and neutron were different. Because they were different. Then next person, who is the next person who introduced another atomic model? Who is the next person who introduced the other atomic model? Ernest Rutherford. What is the name he gave for it? He said it's like a planetary model because it's like the planet, the solar system. So he gave the name as planetary model. Then how did he explain it? He said an atom consists of what? An atom consists of a nucleus. What do you have inside the nucleus? Proton and neutron, right? Inside the nucleus, you have the proton and neutron. And then what did he say? The electrons are revolving around the nucleus in energy orbital. In energy orbital. Did you understand? Did you understand? Good. Right. Okay. Now I'm changing the setting. Now, if you have any doubt up to what we have studied, you can unmute and ask. Any doubt up to we have studied? Yes? Any doubt up to what we have studied?
Miss, should we know the names of the scientists who found about subatomic particles?
Yes. Subatomic particles, not for now, dear. But when you go for grade 10, you should know. Okay?
Okay, Miss.
Miss, are the models about the substance or the atom?
Atom. Now they said no. Now they found out the atom, no. So after they found out the atom, then they found out something is inside there. So what was that substances which was inside the atom?
Electrons, neutrons,
Electron, proton, and neutron. They found out that these substances was there inside the atom. Then now only they got a doubt. Okay, how are they found? So after they got the doubt, how are they found only? What did they introduce? They started to introduce the atomic model. They started to introduce the atomic model. Then who was the first scientist who introduced one atomic model?
J.J. Thomson.
J.J. Thomson. Who was the second scientist? Rutherford. So in grade 10, you will study about another module. But in grade 9, you don't want about that. So did you understand up to these two modules?
Teacher, can you tell the definition?
Yes, teacher.
Sorry?
Teacher, can you tell the definition for atom?
So what is an atom? Atom is the basic unit of a substance.
Is
Okay,
that
when you
enough?
take the substance, the simplest or the basic unit of a substance, you call it as an atom. Right. Now everyone take out the tute. Wait a minute. Everyone take out the tute I gave you. Can you do that soon? Take it out. Okay. Do up to question number 4. Now you should write by your own, okay? Don't refer your book. Do it by your own. So you should do question number 1, 2, 3, and 4. Okay? Do it soon. Do question number 1, 2, 3, and 4. At the meantime, if you have doubt, you can ask me. Others do the 4 questions. Yes. What was your doubt?
Madam, are the model, all of those models in the school book, is it there?
You don't have the plum pudding model. The other model you have, right? So I just taught the plum pudding model just to make it complete. Okay.
Okay. Thank you.
What is the name of the
Teacher, what is planetary model?
So planetary model. Okay, I'll explain now. I think you all can turn to your left and click on my screen, which I have showed the board, right? Can you all do that?
Yes, miss.
Okay. So now what is this planetary model? I'll explain for the people who didn't understand. The others do the 4 questions. If you have not print out the tute, please take out your writing book. Don't write the questions because I don't want to waste time. Write only the answer. Keep space to write the question. So after the class is over, you can write the questions. Okay? Right. Now listen to me. For the people who didn't understand the planetary model. Now, planetary model was a model introduced by a scientist. His name was Ernest Rutherford. What was his name? Ernest Rutherford. Now, what did he say? He gave the word planetary by considering it as a solar system, like a planet, the planetary, the solar system. Now, when you take the solar system, what is there in the solar system? In the center of the solar system, you have the sun. And then around the sun, the planets are revolving around the sun. Right? The planets are revolving around the sun. He told the atom structure is also like this only. He told who is like the sun? He told like the sun, in the center of the atom, you have a nucleus. So that nucleus consists of what? Protons
proton and
and
neutron?
neutrons. He told the atom is also like a planetary system, like a solar system. So in the planet, in the solar system, like the sun, in the atom, you have a nucleus. And he told that nucleus is consisting of what? Proton and neutron. He told that. And then he said, like the planets, the electrons are revolving around the nucleus in different in energy orbital, right? You have energy orbital. This he named it as the energy orbital. And he told the electrons are revolving. You know what's revolving, right? What is revolving?
Rotating.
Rotating. Now you have something, and if it is going around, that we call it as revolving, right? Rotating, right? And they told the electrons are revolving around the nucleus in energy orbital. They have an energy orbital, right? So the electrons are revolving around the nucleus in energy orbital. So that is planetary model. So what is planetary model? He told an atom consists of a nucleus which contains protons and neutrons. And the electrons are revolving around the nucleus in energy orbit. That's all. Understood?
Miss,
Yes.
was this model accepted?
After some days, they rejected it. So you will study that in grade 10. That you said, to be continued. You get in dramas.
Concept of nucleus.
Sorry? I didn't get you. Now you have in dramas, no? So they stop the story at one point and say to be continued. So I'm also stopping at here and say to be continued, right? In grade 10, you will study that this also was rejected for one reason. We'll study the reason and why it was rejected in grade 10. Okay?
Miss, both the models were rejected.
This also was rejected and they introduced another one. Okay?
Teacher, planetary model also rejected.
Yes. But you will study why it is rejected in grade 10. Okay? Because that is not there in your syllabus now. Okay, so have you all finished up to question number 4? If you have finished, can you all please raise your hand? Please raise your hand if you have finished.
Last question.
Sis, should I want to send the pic after doing?
No need, dear. I will discuss the answers here.
Plum
So you
pudding
can
model.
correct it by yourself. Okay?
Okay.
raise your hand once you have finished, okay? So we can discuss the answers. Okay, I think that's enough time. Let's discuss the answers. Take out your red pens, everyone. Take out your red pens. I'll stop the screen share so you can see the board clearly. Right, now take out your red pens soon.
Okay, teacher.
Right, okay, now first question. Name the basic unit of a substance. So what is the basic unit of a substance?
Atom.
Very good. Very good. If you have written atom, correct your answer with the red pen. Don't use a blue pen, okay? Don't use a blue pen. With the red pen, correct your answer. Next one. Name the scientist who's discovered the above basic unit.
John Dalton.
Very good. John Dalton.
John Dalton.
Very good. Right, next one. What are the subatomic particles found in the above unit? Please mute yourself.
Neutrons, neutrons and electrons.
Very good. Proton, neutrons, and electrons. Very good. Fourth one. Okay, I'm muting for the fourth one because I want to say the answer. Right? Okay, fourth one. Explain the following atomic model. So first one, they are talking about plum pudding model. Now, I have forgotten to name the scientist as well. So you all can write the scientist as well, right? So who was the scientist who introduced the plum pudding model? Yes, answer in the chat. Who was the scientist who introduced the plum pudding model? Very good. Very good. So yeah, J.J. Thomson. So first write that, will you? I didn't ask this question, so you can write it with a blue plate, right? So J.J. Thomson. Now I have asked you to explain the plum pudding model. So you should say, an atom is a pudding. An atom is a pudding mixed with plums, right? The plums are the proton, neutron, and electron. So that is plum pudding model, right? So an atom is a pudding mixed with plums. The plums are the proton, neutron, and electron, right? So then next one, planetary model. So who was the scientist who introduced the planetary model? Write it down. Ernest Rutherford. So what did Ernest Rutherford say? He said, an atom consists of what? An atom consists of a nucleus, which contains what and what? An atom consists of a nucleus which contains, yeah, very good, proton and neutron. Proton and neutron. Then he told, and put a comma and say, the electrons are revolving around the nucleus in energy. The electrons are revolving, I'll write it on top, around the nucleus in energy orbital. Understood? Right. Okay. Wait a minute. Okay, the students who got all correct, raise your hand. The students who got all correct, can you raise your hand? Very good. Well done. Very good. Right. Now let's go to the next part. Listen to me very carefully. Now we have studied about atom, right? So next we are going to study about molecules. What are we going to study about? Molecules. Now I'll ask you one question. What is the simplest form of the substance? What is the simplest form of a substance? Yes? Okay, before we go there, go and get a 2-minute break and come. Just drink some water and be back. Drink some water and come back. Let me know when the azan is over, okay? Okay, let's start. Right, now look. So now we are going to study about what? Molecules, right? So now we studied that when you take a substance, the simplest form of the substance or the basic unit of a substance is what? The basic unit of a substance is what? Atom. Very good. The basic unit of a substance is atom. Right. Now look. Now I have two different types of atom. Now I have a circular atom and I have a, say, a triangular atom. Right? I have a triangular atom. Now listen to me very carefully. If two atoms, now say you have a circular atom, a similar atom, you have two atoms combined together. If two atoms combine together, that you call it as a molecule. That you call it as what? Molecule. So say with me, repeat with me, make some noise. So what is a molecule? Two atoms. You have two atoms which is combined together. So when you have two atoms which is combined together, it will form what? A molecule. Now you can have two combinations, right? Now you can have two similar atoms joining together. Or you can have this circle, it has joined with the triangle. So are there similar atoms? If the circle combined with the triangle, are there similar atoms? No, they are not similar atoms. So now what is a molecule? Two or more, it can be two or more, right? Two or more similar atoms or dissimilar atoms. If they combine together, that you call it as what? Molecule. Did you understand? So what is a molecule? Say with me. If two similar atoms, two or more similar atoms or two or more dissimilar atoms combine together, that you call it as what? A molecule, right? Listen again. When you take a substance, the simplest form of the substance, you call it as what? Atom. You can have different types of atoms. There is a lot of atoms, right? So what can happen? Now these similar atoms can combine together. Or there is another probability where these similar atoms can combine together, right? So if two or more, it can be two or more, right? For now, let's take it as here we'll draw two. So if two or more similar atoms or if two or more dissimilar atoms combine together, that you call it as a molecule. That you call it as a molecule, right? So what is a molecule? Let's write it. Two or more. Here is the atom similar or different? Here is the atoms similar or different? Answer me. Is these two atoms similar or is these two atoms different? Similar. So two or more similar atoms or Now look, this and this, are they similar or dissimilar? Or two or more dissimilar atoms, right? Or two or more dissimilar atoms combine together. Combine together. Then that you call it as what? If two or more similar atoms or two or more dissimilar atoms combine together, that you call it as what? Molecule. Molecule, right? Now listen. Now, when you're forming a molecule, you can have two probability. What is the first probability? You all say me. When a molecule is formed, you have two probability. What is the first probability? Similar atoms can combine together. What is the second probability? Yes. Very good. Dissimilar atoms can combine together. Similar atoms can combine together or dissimilar atoms can combine together. Now listen to me very carefully. If similar atoms combine together, for that you call it as homo. Homo means what? Same. Right? Homo is a word when you say same. Right? So here, is the atoms the same or different? Is the atom same or different? Yeah? Same or different? Silent people, answer me soon. Same. So this you call it as homoatomic molecules. What does this mean? Homo stands for the word same. Atomic stands for atom. So what atoms have you used? Have you used same atoms or have you used different atoms? You have used the same atoms. So that's how the word came, homoatomic molecules. You're using the same atoms. Did you understand? So what are homoatomic molecules? The molecules which contain dash. Fill in the blanks. Homo means same. The molecules which contain, very good, the same atoms. If you have a molecule and that molecule is containing the same type of atom, that you call it as homoatomic molecules. Did you understand? Did you understand? Good. Now, next word, hetero. Hetero stands for different. Hetero stands for what? Different. So now you're going to say me the definition, right? I'm not going to explain you. You're going to say me. What is heteroatomic molecules? Can you all say me the definition for heteroatomic molecule? A molecule which is made by two or more, very good, different atoms. Hetero means different, atom means atoms, right? So if you have a molecule which is made by two or more different atoms, that you call it as a heteroatomic molecule. Did you understand? Did you understand? Right. So what is a molecule? So let's revise before we do the question. So let's revise it. What is a molecule? So what is the simplest form of a substance? First answer me that. What is the simplest form of a substance? Very good. Atom. So when atoms combine together, if you have two or more atoms combined together, that you call it as what? Very good. Molecule. If you have two or more atoms combined together, that you call it as molecule. So molecules can be of two types. What are they? Molecules can be of two types. What are they? Very good. Homoatomic molecule. And what's the other one? Heteroatomic molecule. What does the word homo stands for? Homo stands for? Very good. Same. So what's the definition for homoatomic molecules? Molecules which are made by two or more same atoms. So if they are made by two or more similar atoms, that you call it as a homoatomic molecule. So what's a heteroatomic molecule? Molecules which are made by two or more, very good, different or dissimilar atoms. So that you call it as heteroatomic molecule. So is it clear? Is it clear? Very good. Now, do the questions, will you? Can you do the next two questions now? Do the next two questions. Question number 5 and question number 6. Do question number 5 and 6. Soon. Without seeing the book, do it without seeing the book. So you don't need to, like, you should, before you go from the class, you should make sure you can write it by your own. No copying from the book. Without seeing the book, write your answer. If you have finished writing, raise your hand. Once you have finished writing, wait, first I'll put everyone's hand down. Okay, now if you have finished writing, please raise your hand. The class will be over at 6:30, okay? Don't need to write the examples now, okay? After I teach the other part, we will write examples. So don't need to write the examples, just write only the definition. Only the definition, right? The examples, we'll write it later. Yeah, write only the answers. The questions, you can write it after the class. Don't waste time writing the questions. Write only the answers. Please send your message only for RCRE, okay? Don't send your messages for Sateha College. Now only I saw that there is 400 messages here. So this is on top. I can't see. So send your messages to RCRE. Yes, Sauda, like you said earlier, will only those units be used for grade 10 and 11? Yes. If you want the tute, please send a message to this number 077 2345 597. If you want the tute, send a message to this number. I will forward you all the tute. 077 2345 597. This is my phone number. So once the class is over, I will send you all the tute. Ada, leave me a message in WhatsApp. I'll send you the answer, okay? Right, I think that's enough time. So let's see the answer. Right, so now check your answer. First one, what is a molecule? So you should say 2 or more similar or dissimilar atoms combine together, right? 2 or more similar atoms or 2 or more dissimilar atoms, if they combine together, that you call it as a molecule. So what is a homo? Homo means same. So now they're asking you to write the difference between homoatomic molecule and heteroatomic molecule. So you should say homoatomic molecule is made by 2 or more what? Similar or dissimilar? 2 or more similar atoms. Then you should say while heteroatomic molecule is made by 2 or more what? Similar or dissimilar? 2 or more dissimilar molecules. Sorry, atoms. 2 or more dissimilar atoms. Yes, I'll send you all the recording as well. No worries. Right. Okay, now put your pens down and look at the book. Put your pens down and look at the book. Now this part is important. Okay, this one is more important for grade 10. So put your pens down and look at the book. Right. Next, we should study what is an element. Okay, before we go there, let's give some examples for atoms. Right. So when it comes to grade 10, you should mainly remember 20 atoms, only 20. Now, in the earth, you have more than 120. 92, they say in your book, but in earth, you have more than that. But for you all, for grade 10 and 11, you all should remember how much? 20 atoms only. Okay, now I'll write the atoms here, copy it down. So you can do a nice work. You can memorize it now itself and keep it. Okay, so it will be very useful for you in grade 10. Now this chart is not given in the grade 9 book. But I don't want to teach you all just the names like hydrogen, copper, mercury. I just don't want to teach you all the names, right? So I want to teach you all a pattern so that it will be helpful for your grade 10 as well, right? So now draw it with me. Now I have this in the tute. So if you have the tute with you, you can fill it in your tute. Right. 1, 2, 3, 4, 5, 6, 7. You need 8. Right? 8. You need 8 columns, right? You need 8 columns. And then you need 4 rows like this. Okay. Now listen to me. Now this one you call it as the periodic table. Right? You call it as what? Periodic table. So now in grade 10, you should study these 20 elements, right? So now first I want to show you how do you write the symbol for an atom. Now say for an example, you have hydrogen. Now this hydrogen, the first letter of hydrogen is starting. What's the first letter of this hydrogen? What's the first letter of this hydrogen? H. So you symbolize hydrogen by capital H. So if you write capital H anywhere in science, it means that it is hydrogen. So first one will be the capital H. Write it down. Right? The first one is hydrogen, that is the capital H. Next one is helium. Now, I'll ask you one question. Now, when you take helium, the first letter of helium is starting with what? H. So if I write H, does it indicate helium or hydrogen? It indicates hydrogen. So therefore, for helium also, I can't use H. So you use the first 2 letters. So the first letter, you should write it with a capital. The second letter, you should write with a simple. So this is helium. So write the next word, the next atom, helium. Right? So helium, capital, simple, helium. That is the symbol for helium. Right? Next one, lithium. So what is the first letter for lithium? Yeah? L. Right? Always the first letter you should write with a capital L. So for lithium, they use both the letters, the first and the second. So the first letter should be capital. The second letter should be simple. So lithium, Li. Li. Right? Next one, beryllium. So beryllium also we use the first 2 letters. So first letter is B, second letter is simple E, beryllium. Right? Next one, boron. Now for beryllium, we have used the first 2 letters, right? For boron, we use only the first letter. So that is B, boron, right? So hydrogen, helium, lithium, barium, boron. Then next one, carbon. Carbon, you use the first word, that is capital C, carbon, right? Next one, nitrogen. So nitrogen also, you use the first letter, that is capital N, nitrogen, right? Then oxygen. Oxygen also, you use the first letter, that is capital O, oxygen. Then fluorine. Fluorine also, you use the first letter, that is capital F, fluorine. fluorine, right? Then neon. Neon. So neon is this. Now, can I use N for neon? Can I use N for neon? Can I? Yes? No? Can I use N for neon? Answer me, please. Can't. Why? Why is that? Why can't I use N for neon? Because already nitrogen is N. So I can't use N. So what should I use? The first two letters. N, E. N, E. Right? Next one. So next one is sodium. So sodium, the scientific name for sodium is natrium. Right? What's the scientific name for sodium? Natrium. So you use these two letters. Na. Sodium. Na. Right? The next one is magnesium. Right? Now comes the point. For magnesium, you don't say Ma. You say Mg. Sometimes they use the first letter, second letter, sometimes the third one. So Mg. So magnesium is Mg. Right? And then next one is aluminium. Aluminium is what? Al. First two letters. Al. Right? Then next one, aluminium, silicon. So silicon is the first two words. Si. Si. Right? Then next one is phosphorus. So phosphorus, you don't have P here. So you use only the first word, P. Phosphorus. Then next one is sulfur. So do you have an S out of here? Do you have any S's? Do you have any S's? No. So you put an S for sulfur. Right? Then next one is chlorine. So chlorine, you don't use the second letter. You use the first one and the third one. That is Cl. Capital C and simple L. Right? And then next one is argon. So argon, you use the first two words. First two letters. AR. Argon. Right? The next one is potassium. Potassium, the scientific name for potassium is kalium. Right? So we use the first word, K. Potassium. Then finally, we have the calcium. So calcium, we use the first two letters, that is Ca. Right? So this, you should know it in order for grade 10. Right? You should know it in order. So why I'm teaching you here is, it's much easier to know it this way for further studies. Right? So now look. Now in O level, we have certain ways to memorize this. Now this is the way we memorize, right? In Tamil. So we said, hi, hello, listen. BBC, not on Friday. So up to that, it's English. Then we say it in Tamil. Neo, nano, makku, alla. Silukku, poi, solli, kulari, aro, kara, kadavule. We memorized it like that. So there are so many ways to memorize it. So you can try one of them. Okay. So you should know it in order. Hi, hello, listen. BBC, not on Friday. Neo, nano, makku, alla. Silukku, poi, solli, kulari, aro, kara, kadavule. So we memorized it like that. So there are certain ways to memorize it. So you don't need to worry about it for now. But for now, just remember you have a periodic table and you arrange the periodic table in this manner. Is everyone okay with that? Have you all copied this down? Have you all copied this down? Right. Now comes the word. Now comes the main problem. Now listen to me. Now listen to me. Right. Now this one came. Now we know this. Now how did you arrange this? How did you arrange this? So they arrange this by using something. You call it as the atomic number. They arrange this by using something. You call it as what? Atomic number. Now listen to me very carefully. What is this atomic number? Now I'll ask you one question. When I have an atom, so now say I have hydrogen atom. Now, when I take this hydrogen atom, in the center of hydrogen atom, what do I have? Can you all answer me? When you take the hydrogen atom, in the center of the hydrogen atom, what do you have? We studied now. What do you have? Do you have the electrons there? Now, some people are saying electrons. Do you have the electrons? No, the center of the atom is the nucleus. Okay, what do you have inside the nucleus? Do you have the electrons inside the nucleus? Answer me, everyone. Do you have the electrons? No, you don't have the electrons. So what do you have? Very good. You have the protons and neutrons. You have the protons and neutrons. So what they found out is, they found out that this proton is different from atom to atom. But I mean that, now say, if I say hydrogen has one proton. Hydrogen has how many protons? One proton. Will helium have one proton? No. The proton number is unique for an atom. Unique means what? If this has one, no any other atom can have one. Did you understand? Did you understand? I'll explain you again. Look here. When you take the hydrogen atom, you know in the nucleus you have proton and neutron. What did they found out? They found out that this proton number is unique. Unique means what? If hydrogen is having one proton, can any other atom out of this have one proton? Can't. It's unique. Hydrogen one means only for hydrogen you will have one. That means helium should be something different. Lithium should be something different. Two atoms can't have the same number of protons. So that you call it as the atomic number. That you call it as what? Atomic number. So what is atomic number? Atomic number is the number of protons in an atom. So when you take an atom, is the proton number changing from atom to atom? Yes or no? Is the proton number changing from atom to atom? Yes. Can two atoms have the same proton number? Can two atoms have the same proton number? It can't. That means for an atom, the proton number is unique. So what do you call that as? So that number, you call it as what? That number, you call it as what? Yes, atomic number. So what is the atomic number, everyone? Make some noise, say with me. What do you mean by atomic number? The number of protons in an atom. So atomic number is unique. Can two atoms have the same atomic number? Can two atoms have the same atomic number? Can't. So did you all understand that? Did you all understand that? Good. So now what did they do is, they arrange this according to the atomic number. That means hydrogen atomic number is 1. Then what's next to 1? What's the number next to 1? You all know, right? Do you know the number next to 1? What miss you are saying? We are grade 9, no? Yes, 2. Then next to 2? 3, 4, 5, go on, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20. Now if I ask you, what is the atomic number of silicon? What should be your answer? What is the atomic number of silicon? Yes, everyone, answer me. Now you have arranged according to the atomic number. So what's the atomic number of silicon? Very good, 40. What is the atomic number of calcium? What is the atomic number of calcium? Calcium is 17. Now this is chlorine. Cl is chlorine. Calcium is Ca. So what's the atomic number of calcium? Very good. 20. What's the atomic number of carbon? Carbon is C. What is the atomic number of carbon? Very good. 6. Then what's the atomic number of neon? Neon. Neon. N-E. Neon. 10. Very good. What's the atomic number of potassium? Potassium is K. K. Very good. 19. So did you understand? Did you understand? So how did they arrange the atoms in the periodic table? According to what? According to their atomic number. Atomic number. Now I'll ask you one question. What is the proton number of aluminium? What is the proton number? K is potassium. What is the proton number of aluminium? Some people are saying 13. Others, are you all okay with that? They are saying aluminium. The proton number is 13. Is everyone okay with that? Anyone who is objecting is no, miss, I object. I object it. Anyone? Okay, most of y'all are not objecting that. That's correct. Why? We know that atomic number is equal to number of proton. Atomic number is equal to number of proton. So if the atomic number is 13, what will be the number of proton? Number of proton also will be 13. Next one. What's the number of proton for phosphorus? What's the number of proton for phosphorus? Very good. 15. What's the number of proton for helium? Helium. Proton number for helium? 2. So did you understand how to identify the proton number? So if you know the atomic number is equal to number of proton. Right. Next one. And they also found out the number of proton is also equal to number of electron. So this equation you should know. Atomic number is equal to number of proton, which is also equal to number of electron. Now I'll ask you one question. What is the electron number for lithium? Lithium. What is the electron number for lithium? Very good. 3. Atomic number 3. Proton number also 3. Electron number also 3. Understood? Did you understand? So atomic number is equal to number of proton, which is equal to number of electron. Next question. What is the electron number for nitrogen? Nitrogen. 7. So did you understand? Can you identify it? So if they give you the element and say you to find the atomic number, electron number, proton number, can you identify it? Is it clear? Is it clear? Very good. Good. Right. Now come. Now do the next question, will you? First copy this down. This one you should copy it in your tute, okay? If you don't have the tute, just copy it down in your book and then do the next question. So this one only you should copy. Here only you should copy it down, right? And then do 8. 8 first part only. Do only this, only this, and then do 9. Okay, do 8 first part and 9. Do it soon. Because we should study the mass number also before we go. And this. Do those two. Once you have finished, please raise your hand if you have finished. At the meantime, I have changed the setting also. So if you have any doubt, you can unmute and talk.
So, madam, this diagram will be needing this diagram in grade 10, no, madam?
Yes, you will need it in grade 10, but in grade 9, they have given you certain elements from this. So I want to make the work easy for you for grade 10. So if you memorize it now itself, That will be much more easier for you when you go for grade 10, because every chemistry part in grade 10 and 11 depends on this diagram. So however, you should memorize. So find a way to memorize. So like I said, you can memorize it like a song, or there are certain other songs also. There are songs in Sinhala, there are songs in English. So you can go to YouTube and check. So you will get songs on that also. So by using any one of them, make sure to memorize. Okay?
Should we want to write the numbers in elements?
Do you want to memorize the numbers? Do you want to memorize the numbers?
No.
No.
ma'am.
If you know this order, then the number also will be in what order? The same order. Now look here. 1, 2, 3, 4. I have written the numbers in the order, right? Okay.
What is the equation for atomic number and mass number?
Okay, once you have finished, please raise your hand. So I should teach you the mass number also before we go. Before we go, we should study the mass number also. So please do it quickly.
Miss, what is the atomic number for
What is the
sulfur?
equation for mass number and atomic number?
Still, we didn't study the equation for mass number. But what's the equation for atomic number? Atomic number is equal to number of
Protons and number of
proton, which is equal to the number of
electrons.
yes. So that is the equation. Once you are done, please raise your hand.
Miss, what is the
K
atomic
is
number for
potassium.
sulfur?
Sorry?
What is the atomic number for sulfur?
Sulfur. Sulfur where? This is sulfur. Sulfur is S. So sulfur, what's atomic number?
16.
16. Good. 16. Sulfur
Excuse me,
is
miss.
S.
Should we write the equation and what is atomic number also?
No need. Only the equation is enough because you will need only that. But in your exam, if they ask you what is the atomic number definition, you should write it in the definition. So how are you going to write it in definition form? You're saying atomic number is equal to, yeah, atomic number is very good. Only mention the protons for now. Okay, I will say you why we can't say the electrons later. Okay, so you can say atomic number is equal to the number of protons.
Miss,
Right. Yeah. Yes. Right. I think that's enough time. Let's look at the answers because I want to teach you the mass number also before we go. Right. So first they're asking you to write the equation for atomic number. So this is how you're going to write. Atomic number is equal to number of protons, which is also equal to number of electrons. But when you're writing the definition, don't mention that, okay? Which is also equal to the number of electrons. Right. And then next question is asking you to find the atomic number. First one, I think it's sodium, right?
Miss, protons and electrons are equal.
Equal. So what was the first one? Can you all say me the elements? Wait.
The sodium.
Okay, sodium, right? So what's the atomic number of sodium?
11.
Very good. Atomic number is equal to 11. Proton number also will be equal to 11. Electron number also will be equal to 11. Right? So
11.
everything is equal. 11. Next one. So next one was fluorine. Fluorine, atomic number. Now atomic number simple as Z, okay? So we can write it as Z. Symbol of atomic number is Z. So Z is equal to 9. Proton number, let's put it as P equal 9. Electron number also equal to 9. Then next one was sulfur. So atomic number is also equal to atomic number is equal to 16. Proton number also 16. Electron number also 16. The next one, chlorine. Chlorine atomic number was equal to 17, proton 17, electron 17. Calcium. Calcium atomic number is 20, proton number is 20, electron number is also 20. So did you understand? Is it clear?
Yes, teacher.
Yes.
Yes, teacher.
Right. Good. Now let's go to the mass number. Yes.
Excuse me.
Okay, let's go to the mass number. I'll mute you all for some time. Right. Listen to me very carefully. Right. Now, when you take an atom, now this is an atom. Now, what are the subatomic particles found in an atom? Answer me in chat. What are the subatomic particles which is found in an atom? Yes. Very good. Proton. Then, answer me soon. Proton. Then, what else you have? Yeah. Answer me.
Neutrons, electrons.
Answer me in chat. Proton. And you have neutron in the center. And around them, what do you have? Electrons. Electrons, right? Now, they found out the mass of a proton. You can consider it as 1. Mass of a proton is 1. Mass of a neutron is also 1. But mass of an electron is equal to 1 over 1,840. Now, if I simplify this, what will be my answer? 1. 0.000. Then maybe I will get like, say, 5. Approximately, right? I don't know whether it's correct. So I took it as 2,000. So 2,000 means 5. Approximately like that. So now I can say mass of an electron is 0.0005. Is everyone okay with that? Is everyone okay with that? Right? Mass of a proton is 1. Mass of a neutron is 1. Mass of an electron is 1 over 1,840. So if I simplify this, I will just approximately get the answer as 0.0005. Right? Okay, now look. Now say you're going to the shop. Okay. Now you have a bag. You're filling the bag with, now say example, you have 1 kilogram of rice. And you have another 1 kilogram of dal. Say you have 1 kilogram of dal. Now this bag, mass of this bag is 0.0005 kilogram. Very small. Now bag is not so heavy, no. So it's very small, no. So mass of the bag is 0.0005. Now if I ask you the total mass of this, what will be your answer? What is your answer? I'll explain you one more time. Now, when you take an atom, you have proton and neutron as well as you have electron. They found out the mass of a proton is 1. Mass of a neutron is 1. But mass of an electron was 1 divided by 1,840. So that 1 divided by 1,840, what was the answer? 0.0005. So same like that, I'm just comparing another example. Okay, you have rice 1 kilogram. You have dal 1 kilogram. The mass of this bag is 0.0005 kilogram. What is your total mass? You add everything. So 1 plus 1 plus 0.0005. So what's your answer? What's your answer? Is it 2.5? No, it's not 2.5. You add 1, 5, 0, 0, 0, 0.1 plus 1, 2. Right? So that is 2.0005 kilogram. Am I correct? Am I correct? So now when you're saying for the customer, now the customer wants this. So when you're saying for the customer, you say this is approximately equal to how much? Approximately you say, okay, I have 1 kilogram rice, 1 kilogram dal. This is 0.0005. Approximately this is equal to how much? If you round it off, 2 kilogram. 2 kilogram. So did you understand this? Did you understand this scenario? You have this, but this is a very small value. So you have rejected it. So you are saying approximately it's equal to 2 kilogram. Right? So same like that, when you take the mass of an atom, if you take the mass of an atom, so mass of an atom should be number of proton, number of neutron plus number of electron. Am I correct? Now you should add all things. No. Now this is an atom. You are going to find the mass. How heavy the atom is. So that means I should add the number of proton, number of neutron, and number of electron. Am I correct? I should add everything together. So if I add it, what will happen? Now say this is 1 plus 1 plus 0.0005. So what will be your answer? What will be your answer? What will be your answer? 2.0005. But when you are saying your answer, you say approximately it's equal to how much? Approximately it's equal to how much? 2. 2. Right? So what have you done? Did you consider the mass of a proton, the electron? Did you consider the number of electrons? No. So therefore, when you're considering the mass of an atom, you don't consider the number of electrons. So mass of an atom is equal to number of proton plus the number of neutron. You don't consider the number of electron. Did you understand? Did you understand? Yes? No? If you know, just let me know. I'll explain you again. No problem. No problem. Okay. I'll explain you one more time. I'll explain you one more time. Now, when you're considering the mass of an atom, what should you do? You should consider everyone's mass. What do you have inside an atom? You have the proton, you have the neutron, as well as you have the electron. So when I'm considering the mass of an atom, I should add the proton number, I should add the neutron number, as well as I should add the electron number. But when they said the electron, the mass of an electron is 1 divided by 1840. So that means it's 0.0005, which is a very, very small value. So when you're adding everything, do you consider approximately, you say this is 2. So do you consider the number of electrons? Do you consider the number of electrons? No. Right? So therefore they say mass number is equal to number of proton plus number of neutron. Now you will ask me, Miss, do we need to know? Now, this is a logical way to understand, right? You should know when you're considering the mass of something, you should add everything. So in grade 10, they will ask you, why didn't you add the electron? What should be your answer? Why didn't you add the electron? Now they can ask you in the exam. Now mass number means you should consider everything. But you're not considering the number of electron. Why is that? What should be your answer? Because it's very, very, why did you take 2.005 as approximately 2? Because this value is very, very small. Very, very small. Did you understand? So that's why you don't consider the mass of an electron. Is it clear? Is it clear? Right. I'll ask you one question. Now they have given you potassium. Atomic number of potassium is 19. Neutron number. Neutron number of potassium is 20. 20. What is the atomic number? What is the atomic number of potassium? Look at the chart and let me know. Potassium, K. Now you drew a chart, right? Look at that chart and let me know. What is the atomic number of potassium? K. K is how much? Is it 20? Did we write it as 20? Potassium, calcium. Potassium is how much? 19. So if the atomic number of potassium is 19, what should be the proton number? Atomic number is equal to number of protons. So if the atomic number of potassium is 19, what should be the proton number? Very good. 19. Now find me the mass number. Now what is the mass number? Number of proton plus number of neutron. Proton is 19 plus number of neutron is how much? Number of neutron is 20. So 19 plus 20, how much? Very good. So the mass number of potassium is 39. Did you understand? Did you understand? I'll give you another question. You have, say, sodium. Sodium neutron number is 12. Neutron number is 12. Find the mass number. Now look at the chart they have given you. Sodium, in the chart they have given you, the neutron atomic number of sodium is how much? Atomic number of sodium is? Look at the chart. Look at the chart. Now you copied the chart down, no? Atomic number of sodium is what? Sodium is Na. Very good. Atomic number is 11. So what will be the proton number? If atomic number is 11, proton number also will be? Very good. 11. So what will be the mass number? Proton number 11. Neutron number 12. 11 plus 12. Now some people are saying 32. Is it correct? 11 plus 12 addition. 3, 2. So what's your answer? 23. Did you understand? Did you understand? Is it clear? So do you know how to find the mass number now? Right? So for when you are finding the mass number, you should use the equation. Mass number is equal to number of proton plus number of neutron. How are you going to find the proton number? How are you going to find the proton number? How are you going to find the proton number? By using what? Proton number is equal to what? Proton number is equal to atomic number. So by using the atomic number, you can find the proton number, right? I'll give you another one question. Say chlorine. Chlorine neutron number is 18.5. Find the mass number. Neutron number is 18.5. Look at your chart. Look at your chart and find out what is the atomic number of chlorine. Atomic number of chlorine is how much? Look at the chart and let me know. Look at the chart you drew and let me know what's the atomic number of chlorine. Very good. Atomic number is 17. So if the atomic number is 17, what will be the proton number? 17. So now you add. So mass number is equal to proton, that is 17, plus neutron, 18.5. So what's your answer? Is it 35 or 35.5? So when you are writing the decimal, the whole number you should write first. After that only you should write the decimal, right? So 0.5. So this one, 15. One remainder, 35.5. Understood? Is it clear? Good. So now for homework. Before you come next week, do this for homework, right? Don't come without doing the homework. So for homework, you should do the highlighted ones. Wait. This one, you should write the equation for mass number. And then you should do question number 10. Question number 10. Okay. So that's it for today. So if you have any doubt up to what we have studied now, you can unmute and ask. If you have no doubts, meet you all next week. Take care. Bye. Yeah.
Thank you, teacher.
Welcome, dear.
Excuse me, miss. How
If
to
we have
find
any
neutrons?
doubt, we have to
Sorry?
take the writing book. Should we take this out again?
Give the neutron
Okay,
number.
wait. One person at a time. Right. Okay. How to find what?
The mass of neutron?
How to find the neutron number. Now, this is what they will do in the exam. They will either give you the mass number and say you to find the neutron number, right? But they will not directly ask you the neutron number. Now, say for an example, in the exam, they have given you the mass number of sodium is 23. Now, you know the atomic number, no? Atomic number is equal to number of protons. So, atomic number of sodium is 11. So, you know 23 is equal to number of proton is 11 plus neutron. So what will you do? Here addition, if you take it this side becomes
Minus.
23 minus 11 is equal to neutron. So what will be the neutron number? 12. So there you don't need to memorize it, right? You don't need to memorize it. They will give you. They will either directly give you the neutron number, or they will give you the mass number and ask you to find the neutron number. Okay?
Okay, miss. Thank you, miss.
Welcome. Yes. Next
Excuse
person.
me, miss.
Yeah.
If we have not taken a printout and wrote everything in the writing book, is it necessary to take a printout again?
If you have written in the writing book, make sure you write all the questions and keep so you can write the answers when I'm discussing with you.
Okay, miss. Thank you.
Welcome.
Thank you, miss.
Welcome.
Assalamu alaikum.
Alaikum salam.
What is the
Thank
number
you,
of
Miss. Great job.
What is the
symbol?
what? I didn't get you. One person asked.
What is the symbol of atomic number?
Atomic number symbol is Z.
Mass number?
Mass number is A.
Thank you.
Welcome.
Thank you, ma'am. Jazakallah.
Barakallah. Take care.
Excuse me, miss.
Yeah.
Teacher.
Is the
Welcome.
number of neutrons always less than the number of protons?
No, you can't say like that. It changes. Now, when you say proton for sodium is 11, no. Neutron is 12. So, is 12 less than 11?
No.
Teacher, symbol A defines what?
Mass number.
Thank you, ma'am.
Okay. Then, if you have any more doubt, you can leave a message to this number. Okay. Leave a message to this number 077 2345 597. Right. So, I'm ending the class.